Okay, welcome to New Science YouTube channel. In today's lesson, we are going to be looking at derivation of logarithmic function. Given the function y equals log s base a, we intend to find the derivative of this function. Now, suppose there is a small change in y, s is going to change accordingly. So I'm going to have y plus change in y equals log x plus change in x is a. Now, change in y equals log x plus change in x base a minus y. So I'm substituting this for y into this. I'm going to have change in y equals log to the base of a x plus change in x minus log x to the base of a. Now, applying the law of indices or logarithms rather, I'm going to have change in y equals log to the base of a into x plus change in x divided by x, because since we have a common base, we apply the law of logarithm for subtraction. So this is going to give us change in y equals log to the base of a. Divide this by this, we will have 1 plus delta x all over x. Now we just need a little bit of manipulation to manipulate this. I'm going to have divide both sides by change in x. So I'm going to have change in y divided by change in x is going to be equal to 1 divided by change in x into log a, log base a to 1 plus change in x all over x. Okay, let's do a little bit of manipulation on this. So if I multiply both the numerator and the denominator by x, I will still return back to this. So I can just push this, shift this up. So I'm going to have x 1 over x times x over change in x. So you see that when I cancel out this, it's return us all back to this. This is change in x into the logarithm to base a of 1 plus change in x all over x. So by applying the law of logarithm again, remember that if we have a logarithm of p log m to base a, that becomes log m to the power of p base a. So I'm going to apply this law of logarithm to this here. So I'm going to shift this upward. So by doing that, I'm going to have change in y over change in x. Okay, let me add this to this place. Change in y over change in x is equal to this. It's going to be equal to 1 over x logarithm to both base a into 1 plus change in x over s raised to power x over change in x. Now, if the limit of x, the limit of x tends to 0, then x over change in x must tend to infinity. So as such, I'm going to have this change in y over change in x equals 1 over x log, this should be limit change in x, the limit of change in x tend to 0. So x divided by change in x gives us, if it tends to what? Infinity. So I have 1 over x divided by 1 plus, so I can change this to change over x over s is the same as 1 over x over change in x. I just want to make this in form of this. So I have 1 over x over change in x raised to power x over change in x. Now this function here Okay, there's a base there. 1 plus 1 over s change in x raised to power x over change in s becomes e when this changes to infinity. So therefore, the whole of this equation, when I have delta y dx, delta s tends to, the limit of delta s tends to 0. So I'm going to have this 1 over s log e, log base a, then this becomes what? E. So therefore, the y dx equals 1 over s log e to base a. Now let's assume that, so now if I put a equals e, then this function becomes the y dx is equal to 1 over x log e base e, and any logarithm, this will cancel out this. So therefore, the y dx is equal to 1 over s. So we can see that the differentiation of e to base x to the power of s, or d ds base s, that will also give us what? E to the power of 1 x.